Good evening. We'll look into this practical. So now we have some questions pending, but we haven't derived beta 1, gamma 1, beta 2, gamma 2 yet. So we'll look into this in the next class or in the theory class. After deriving the coefficients, I'll take this and I'll give you the answer for those questions. Today we'll start from this question. So it is again similar to that of binomial distribution. You will have to fit a Poisson distribution, and then you have to generate the samples. Now fitting is very easier. Fitting means you have to obtain the parameters. So either from the observed data, or if it is known priorly, you can use that. So if the lambda is computed from the data, then using that lambda, you have to compute all the probabilities. Once you extract all the probabilities, you have to compute the frequencies, where frequency is indicated by P, and it is equal to n into P, where n is the total frequency. Okay, so we'll take the first question. So question says fit a Poisson distribution. So lambda is not given, so we have to estimate the lambda. So one of the method of estimating lambda, as said in the previous class, is method of moments, where it will compute the sample moment and equate it to the population moment. So we talk about moments about origin here, and lambda is nothing but the mean of the population. So we will compute the mean of the sample distribution and equate it to lambda. So we have lambda is equal to x bar. Whereas in case of Poisson distribution, binomial mean is np. So to find p, we'll use x bar, n into p equals x bar, p is equal to x bar by n. Okay, so we have x values given, f values given. So we'll compute f into x. So compute the total, which is this 80, 86 either 186 and 72. Fair enough. Compute sample mean. X bar is equal to sigma f x by sigma f. Formula baribeko. The total is correct. ಯಾರಿದು ಗಲಾಟೆ ಮಾಡ್ತಿರೋದು? ಸೋಮೇಶ್ ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳೋ. ಏನೋ ಸುಮಾರು ದಿನ ಆಯ್ತು ಕ್ಲಾಸಲ್ಲಿ ಶಬ್ದನೇ ಇಲ್ಲ ನಿಂದು. ಶಬ್ದ ಮಾಡಿದ್ರೆ ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಂತೀರಾ. ಟೋಟಲ್ ಸರಿ ಇದೆಯಾ? ಕ್ಯಾಲ್ಕುಲೇಟ್ ಇಟ್ಕೊಂಡಿಲ್ವಾ ಯಾರು? So we'll get mean as 2.533. So lambda is equal to 3. So lambda equals population mean. So yeah,
So 0.3871 ಬರುತ್ತೆ ಸರ್ ಮೀನು.
ಟೋಟಲ್ ಸರಿ ಇದೆಯಾ ಅಂತ ಹೇಳಿದ್ರೆ ಸುಮ್ಮನೆ ಇದ್ದೀರಾ?
72 by 186.
So 72 divided by 186 sir. 3871 sir. 3871.
Okay. Okay. So we have lambda. Okay. Now once we have lambda, we can easily obtain the probabilities. So write the PMF, compute probability for x is equal to x, and then compute P of x. Show the working for 1 or 2, and then you can obtain it for the remaining case. Bariri PMF bariri first probability ಮಾಡಿ. And to compute the last probability, the last value of x is actually not 4, but it is 4 or more. So this happens almost in all the fitting problems of Poisson. But for the computation of mean, we'll take it as only 4. But while computing the probabilities, we should compute the probability for P of x greater than or equal to 4. So to obtain this, you will have to look into the sum of all the previous probabilities, that is x less than 4. So I'll compute P of x equals 1, P of x is equal to 2, and then P of x equals 3, P of x equals 4, and use this in obtaining P of x greater than or equal
Sir,
to
x equals 3, x equals 4, 0 ಆಗ್ಬಿಡುತ್ತೆ.
0 ಆದ್ರೆ ಒಳ್ಳೆದಾಯ್ತು. ಇದೆಷ್ಟು ಬಂತು ಫಸ್ಟ್ ಒನ್?
0.6790.
0.6. Next one now.
0.4611.
0.4611. Okay. 2.
0.0490. Next one.
0490. So
Yes,
this
sir.
will be
For P of x greater than
1
0,
minus
sir.
0.6790 plus 0.46. So that comes to 0. Okay, now write them in the table. Check for the sum, that should be equal to 1. And then you have capital N. So again, that is also given. Given N is equal to sigma F. That is 186. So multiply every probability by 186. Then generate the price. As far as possible, you have to write the integer value. So approximately equal to 126. Then this is
P of x equals 1 ತಪ್ಪಾಗಿದೆ ಸರ್.
ಯಾವ್ದಮ್ಮ?
P of x equals 1.
ಎಷ್ಟು ಬರಬೇಕು? e power minus lambda, lambda power 1 ಅಲ್ವಾ? e power minus 0.3871 into 0.3871.
ತಪ್ಪಾಗಿದೆ ಸರ್, ನಾನು ತಪ್ಪು ಮಾಡಿದ್ದೀನಿ. 0.2628 ಬರ್ಬೇಕು ಸರ್. ಸೆಕೆಂಡ್ ಒನ್
0.262.
0.2628.
ಥರ್ಡ್ ಒನ್
Third one 0.2035.
0.0509.
P of x equals to is
0509.
0.0509. Okay. Next one.
0.0066.
0.0066. So this changes. This comes to 0.007. Nine, two. Let us check the total. Total should come to 186. If not, you have to adjust. Okay, so it is coming 186. So I can take this as 0 only. So if the total was 185, then you could have taken the last frequency as 1. So ಕೆಲವು ಸಲ less than 0.5 ಇದ್ರೂ approximation next integer ನಡೆಯುತ್ತೆ. So adjustments ಅಲ್ಲಿ total observed frequency, total expected frequency same ಬರಬೇಕು, ಆ ತರ ನೋಡ್ಕೋಬೇಕು. Now sometimes in these questions they will only give you the value of lambda. Like say the question would be fit a Poisson distribution by taking lambda as 0.5, by taking lambda as 1, by taking lambda as half. So ಈ ತರ questions ಇರುತ್ತೆ. ಅವರೇ ಲ್ಯಾಂಬ್ಡಾ ಕೊಟ್ಟಾಗ ನೀವು ಎಫ್ ಇಂಟು ಎಕ್ಸ್ ಮಾಡೋದು, ಮೀನ್ ಕಂಡುಹಿಡಿಯೋದು ಅವಶ್ಯಕತೆ ಇರೋದಿಲ್ಲ. ಬಿಕಾಸ್ ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ನೋನ್, ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಜನರೇಟ್ ದ ಪ್ರಾಬಬಿಲಿಟೀಸ್ ಆಸ್ ವೆಲ್ ಆಸ್ ದ ಫ್ರೀಕ್ವೆನ್ಸೀಸ್. ಆಯ್ತಾ? ಅರ್ಥ ಆಯ್ತಾ ಇದು? ನಾ ಡೌಟ್ ಇದೆಯಾ ಇದರಲ್ಲಿ? Is it done?
ಸರ್ ಲಾಸ್ಟ್ ಅಂತೂ 1 ಆಗ್ಬೇಕು ಸರ್. ಇಲ್ಲಿ ಟಿ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಅಲ್ಲಿ ಟೇಬಲ್ ಅಲ್ಲಿ ಸರ್.
ಹಾ, ಟೋಟಲ್ 1 ಬರ್ತಿಲ್ವಾ?
ನೋ ಸರ್, ಅಲ್ಲ ಅಂದ್ರೆ ಟಿ ಆಫ್ ಎಕ್ಸ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಕಾಲಮ್ ಅಲ್ಲಿ ನೀವು ತಪ್ಪು ಮಾಡಿದ್ದೀರಾ. 0.1302 ಬರಲ್ಲ, 1.3478 ಬರುತ್ತೆ.
1 ಪಾಯಿಂಟ್ ಅಲ್ಲ, ಲಾಸ್ಟ್
3478
ಪ್ರಾಬಬಿಲಿಟಿ ಸರಿ ಇದೆ ಅಲ್ವಾ? ಆರ್ ದೀಸ್ ಪ್ರಾಬಬಿಲಿಟೀಸ್ ಕರೆಕ್ಟ್? ಚೆಕ್
ಸರ್
ಯುವರ್
probability is correct sir. T of x is equal to x ಟೇಬಲ್ ಅಲ್ಲಿ ನಾನು ಹೇಳ್ತಾ ಇರೋದು.
ಹಾ, ಫಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಬಂದಿದೆ?
126.940.
940 ಹೆಂಗ್ ಬಂತು? 186 ತಾನೇ ಟೋಟಲ್ ಇರೋದು.
ಹಾ,
so 186 into 0.679 gives you 126.294.
Sir, 1.22 approximates to 1 alva sir.
Okay, ಸರಿ.
ಆಮೇಲೆ 9.46
ಆಮೇಲೆ ಲಾಸ್ಟ್ ಸರ್ 1.3478 ಆಗುತ್ತೆ.
ಇಲ್ವಲ್ಲ, ಬರ್ತಿಲ್ವಲ್ಲ. 0.0007 ಅದು, ದಟ್ ಇಂಟು 126, ಸಾರಿ 186. ನೋಡು, ನೀನ್ ಬರೀ 3 0 ತಗೊಂಡಿದ್ದೇನಾದ್ರು. 0.13 ಬಂತು. ನೀವು 3 0 ತಗೊಂಡ್ರೆ 1.3 ಬರೋದು. ಸಾರಿ, 2 0 ತಗೊಂಡಾಗ. ಸೊ ಇದು 1 ಆಯ್ತು ಅಂತ ಅಂದ್ರೆ ಈಗ 9.4 is the number which could be approximated to 10, so that the total becomes 186. Okay, so these adjustments ನೀವು ನೋಡ್ಕೊಂಡು ಮಾಡಬೇಕು. You can take the last one also as 1, ಅದು ಮಾಡಬಹುದು. You can have frequencies 126, 49, 911, that is also fine. But 9.46 is, 0.46 is very near to 0.5 compared to 0.13. So we'll approximate 9.46 to 10 rather than approximating 0.13 to 1. ಬಂತ ಇದು? 0.13 ನ ಬಂತಲ್ವಾ?
Yes sir.
Okay. We'll do the next one. Next one is also almost same. ಒಂದಕ್ಕಾದ್ರೂ ಲ್ಯಾಂಬ್ಡಾ ಕೊಡ್ಬೇಕಿತ್ತು ನಾನು. Okay, so x is the number of misprints, f is the number of pages. So we have 0, 1, 2, 3, 4 and more. Frequencies 32, 45, 15, 7, 1. So lambda is not given. You will compute fx, and from that you will generate the probabilities and frequencies. Now in this case, we'll use recurrence relation for one problem. It is not theoretically done, but let me give you that it is very easy. Compared to binomial, recurrence relation in Poisson is very easy. P of x is equal to x current probability is equal to lambda by x into lambda divided by x into previous probability. So I'll compute the first probability using the PMF. So this will be e power minus 1 into 1 power 0 divided by 0 factorial 0.3678. Now use the recurrence relation. So recurrence relation, this works for x is equal to 1, 2, 3 onwards.
सर minus 0.3678 बता दे.
ಆಯ್ತಾ? First already ಬಂತಲ್ವಾ? Now take x is equal to 1 in the recurrence relation. So I'll get p of x is equal to 1. When you substitute for lambda and x, lambda is 1, and in this step we have taken x is also also 1. So into P of X equals 1 minus 1, which is 0. So it is 1 times of previous probability. So it is 0.03678. And remember this, whenever you have lambda equals 1, first and second probability are same. Lambda equals 2, second and third probability will be same. Okay, next in the recurrence relation, take x is equal to 2. You get P of x is equal to 2 is equal to lambda by x. Now x is 2 into P of x is equal to 2 minus 1, which is 1. So this becomes 0.5 times of 0.3678, which is 0.1839. Now taking x is equal to 3, we have P of x is equal to 3 is equal to 1 divided by 3 into P of x equals 3 minus 1, which is equal to 2. So this becomes 0.333, which is 1 by 3 into previous probability, which is 1839. And next one is P of x greater than or equal to 4. So we can't use this relation. ಏನಂತ ವ್ಯತ್ಯಾಸ ಬರೋದಿಲ್ಲ, but procedure follow ಮಾಡಬೇಕು. X greater than 4 is 1 minus P of x less than 4. So which is 1 minus the sum of 0.3678, 0.3678, 0.1839 and 0.0613. How much is that? Comes to 0.9808 alva. So 1 minus 0.9808.
Sir, sir, e to the power of minus 1 no 0.3679 alva sir.
367978 ಎಲ್ಲ ಒಂದೇ ಅಲ್ವಾ? ನಾನು ಇಲ್ಲಿ ಕೆಲಸ ಫಿಕ್ಸ್ ಮಾಡ್ಕೊಂಡಿಲ್ಲ, ಮಾಡ್ಕೊಂಡು ಮಾಡಿ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಸ್ವಲ್ಪ ವೇರಿ ಆಗುತ್ತೆ ಆಗ್ಲಿಕ್ಕೆ. So you can change it. ನೀವು 0.979 ತಗೊಂಡು ಮಾಡ್ತೀರಾ ಅದೇ ಮಾಡಿ, ತೊಂದರೆ ಇಲ್ಲ. ನೋಡ್ಲೇ ಇಲ್ಲ ಫಿಫ್ತ್ ಡಿಜಿಟ್ ಇದೆ. You have the same recurrence relation for frequency also. So instead of writing px on either side, you will write px. So steps will be similar, but you will be computing the frequency at the first and use the frequency values.
Sir, ಅದೇ ರಿಕರೆನ್ಸ್ ರಿಲೇಷನ್ ಯೂಸ್ ಮಾಡಿದಾಗ 0.01532 ಬರ್ತದೆ ಸರ್ P of x is equal to 4 ಗೆ.
ಅದೇ ಈಕ್ವಲ್ ಟು 4 ಬರುತ್ತೆ, ಬಟ್ ನಮ್ಗೆ ಈಕ್ವಲ್ ಟು 4 ಬೇಕಾಗಿಲ್ವಲ್ಲ. ಅವರ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ x is equal to 4 or more. Question ನೋಡಿ, if value is 4 and more, so it is not just x equal to 4, it is x greater than or equal to 4. So that probability has to be written there. 0.0613 by 4, 0.153 ಏನು ಬರುತ್ತಲ್ವಾ. Now compute the frequency. So every value into 100 So it is 37, 18, 6 to 63. So total comes to 100. Direct indicators ಬರಿಬೇಡಿ ನೀವು tx ಬರೆದು approximation ಬರೀರಿ. ಆಯ್ತಾ ಇದು? So when the next one is also same fitting, you have different values for x and frequencies. So 3 and 4 you have to do. And let me take you through the fifth one, generation of the random sample. Okay, so if you remember the generation of binomial, there we had the values of n given. So the value n indicates what are your values of x. So where you will have x up to. But here we don't know what is that maximum value of x, but we know that it doesn't take infinity. At some point of time, we'll observe the probabilities to be equal to 0. So I have to compute the probabilities till you observe probabilities going to 0. And then you write x values till there. So I've taken up to 10. So I'll see if some more are required, I'll write. If not, I'll omit some of the values. Now what does the question says? I have to generate 15 values from this bucket of x, where I have lambda is equal to 1.5. So since lambda is known, I can easily compute the probabilities. So we have the PMF. You can use the recurrence relation also here to generate the probabilities, but many of us feel that the PMF itself is easier than recurrence relation. You will not worry about that. Okay, so we have the PMF. Now use this and generate the probabilities. Onde ಮಾಡಿ. So now the Excel code to generate the Poisson distribution is Poisson is equal to Poisson x comma mean ಅಂತ ಕೇಳುತ್ತೆ. We know that mean is lambda, and then cumulative if you want to generate the cumulative probabilities. You can see that the probability goes to 0 when you have x is equal to 9. So it's enough you take your x values up to 9. So 10 is not required. ಮಾಡಿ ಜನರೇಟ್ ಮಾಡಿ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಇಟ್ಕೊಂಡು ಬೇಗ next next, what are the next steps? Next, we'll need the cumulative distribution function, which is nothing but p of x less than or equal to x. And then we'll write the interval. And then we need random numbers. And then we'll have the random sample. So first interval